Thank you for coming. We're going to start with a prayer. Would anybody like to volunteer to say it? Want me to give you daggers? Thank you.
Dear Father, we're grateful for this day. We're grateful that we could all meet here and please you. And we're grateful for the opportunity to be a part of this. And pray for our instruction today, that we'll be able to teach us and be able to have a good time as we increase in our understanding together. And we say these things in Jesus Christ. Amen.
All right, so this has happened. We finally got a whole bunch of parts. We've got wires, we've got motors, we've got controllers. In the Mindstorm Rumble, this whole idea that we created at the very beginning of the semester was that we'd have this robot competition. It would go over an obstacle course. There'd be points. There'd be a system of being able to determine a winner, that we have established rules and everything. Well, the parts are here after a long, drawn-out deal of drama of just getting to this point. There's enough to get started with your robot. There might not be enough for all the parts that you're looking for, but it's a really good start because now you can actually start building your interface and stuff. The next thing is we have two guest presenters today. We've got Joe, what's your last name?
Tracy.
Joe Tracy. He's going to be giving a presentation on NoSQL and relational databases, to being able to know the pros and cons between them, when to use them, when not to use them, the differences, so on. Just an overview, I guess. And then we'll have Dylan Little, which we last heard is on his way, and he should be giving a presentation on how to do cross-application development using C#, because with Microsoft recently purchased a company called Xamarin, and they are responsible for creating a build system that lets you compile from one language onto different application platforms like iOS, Android, and Windows Phone using C#. And so he'll be giving a presentation on that. And so we'll get started. I'll turn the time over to Joe. Let's get you set up. Got to get you hooked up and wired into the presentation. What's your Gmail account, Gmail address?
Tracy.1992.
Edward, Joseph Tracy.
1992. Joseph Tracy.
Hey Dylan. So if you go into web browser, hangouts.google.com.
Right, and am I joining the call or am I starting the call?
You're joining.
Yeah, you're going to be invited.
I hate being the call leader. Did you send me an invite?
Yeah.
Can you read back the email address?
There it is. There it is.
Here we go.
There it is.
You sent a message, I will accept. I accept it.
That part, and we'll share your screen. You're going to want to mute his microphone immediately. It will ask you to accept the terms when it connects. There it goes.
I read it. Of course I did.
Broadcasting.
You just signed away.
So when we go to this, I'm going to share your entire screen. And you can switch over to your Fedora. All right. Thank you for waiting. There you go.
I forget where the play is on this. That'd be so convenient. I never use PowerPoint for anything. Hate it. And is this going to get on the main screen?
Yep. If the projector turns on, here it goes.
Sweet deal. All right. My name is Joseph Tracy. I'm the head TA for the database program here on campus under Casey Moffett, if you know him at all, but he's leaving next semester. I'm focusing today's presentation on SQL versus NoSQL. SQL standing for Structured Query Language, and No actually means basically not only SQL.
I also work for security here on BYU-Idaho for information security. I see your browsing history. Remind everyone.
Oh, I use VPNs.
As long as it's not cool. Depends. Is it tunneled or is it direct?
Depends.
Well, I'm seeing that you're never credentials, so they're still probably under your username. So flags. Also, I interned with Oracle in the Application Technology Group Support Center down in Lehigh, Utah. If you've seen that new building, it was fun. I was the first intern in like the 14 or 15 years since I last had intern. It was exciting. Had free soda. I'd recommend working there. Now, the topic I'm going to cover today over SQL databases and NoSQL. They're pretty similar between the two of them. SQL standard characteristics, database examples, and pretty much the same thing for NoSQL. Starting off, does anyone have any questions generally, so you don't have to think about it the entire presentation about SQL versus NoSQL? Yes.
What's the difference?
What? That's like my entire presentation. Good question. Okay, so the SQL standard, whenever you have a SQL database, you have a couple of things that are pretty much generic across any instance or any management system you use for your database. All your data is going to be stored in a logical table, very similar to Excel, with rows and columns into tables, that each tables have relationships between each other. And you use DML and DDL, which, if you're not familiar, it's data manipulation and data definition, which determines to the SQL database how data should be handled. You have transactions. As a side note, one of the best arguing points for SQL is asset compliance, which we'll get to in here in a minute, but mostly for transactions. SQL databases are great for finance because it checks and double checks every transaction making as a database. And also there's abstraction from the physical layer. Oh, that was a copy. Whoops. All right. As for abstraction, applications specify what they want, not how. So your SQL database can handle data the way it wants. You have a query optimization engine, and you can modify your physical layer without changing the applications that uses it. So you can create indexes to support queries and have in-memory databases. Oracle recently made, I think like 2 or 3 years ago, something called Exadata. It's basically just a huge honking server that has 128 terabytes of RAM, and you load your. I know it sounds ridiculous, right? And what it does is actually pretty cool. It keeps the entire database on RAM, so all your queries are just like instantaneous, right? Even though they have SSD storage for those machines, you never touch it except for long-term storage. I know, like it's like the minimum the minimum specification is like $2 million. Yeah, it's big stuff. Data manipulation language. If you're familiar with SQL at all, you'll have select, insert, update, and delete statements. This is how you manipulate and handle data inside your database. This isn't the data structures. This is the actual data itself. SQL is good for data aggregation, compound statements, functions and procedures, and explicit transaction control. If any of you are familiar with object-oriented programming, SQL uses that a lot, which makes it very convenient to have a small library or a small product. What am I thinking of? The P word. I had this all prepared mentally before. I should have had note cards or something. But it makes it really easy to have a library and to call against that library, even have it being dynamic. So you don't have to have a library for each and every transaction you want.
Are you looking for properties?
You can use properties. SQL databases support record types, procedures, functions, and one other thing that's escaping my mind. But you can use properties and just about everything else you could do in C, Java, or thank you, C#. Sorry, I just got back from work. My brain isn't all here yet. Data definition language. This is how you specify how data relates to each other and how the data is stored. Now, SQL, generally speaking, is a very, very structured environment. You cannot insert data until there is a place to put the data. And you can't have a place to put the data until the database is up and running. You have users. It's very structured. You have to have an entire implementation set up before you actually start using it. There's pros and cons to this. The pro is, as long as you put the thought in beforehand, your solution can be very, very efficient and accurate for what you need it to do. The downside is, if you need to make changes later, you have to be very knowledgeable on how to make the changes and what changes need to be made. Else, you could end up breaking something in your database. Now, ACID compliance. This is something that's very, very important for any SQL database. ACID does 4 things, and you can see here: atomic, consistent, isolated, and durable. Each of these 4 categories basically just means that whatever data you're working with, that any changes, reads, or updates to the database, that it's always going to be correct. Like, let's say, for example, you have 3 people in your database, and they're all looking at the exact same table. Each person can query and get a call for all the data and for what they need, but when they want to commit a change, they'll actually have an ID with their cursor. You guys know what cursor is, right?
Your position.
Basically, it's the data you've pulled back. It's that specific. So it comes with an ID, and when you actually try to commit changes, it'll check your ID with the cursor ID on the table to see if you're the most recent person. If not, you actually have to re-pull the data, review it again, and then commit changes. The con is it's really annoying if you got a lot of people on the same database. But the pro is your data integrity is exceptional. You're not going to lose data over multiple people editing the same thing at the same time. And here are some examples of what SQL databases are out there. You have IBM, Oracle, Microsoft SQL Server, Sybase SQL, MySQL, Ingress. I'm pretty sure you guys have heard a lot of these before. Now we go to NoSQL. NoSQL is generally viewed as the next generation of SQL. They say this because it's supposed to be easier to work with, handles more data, and is more robust. Here are some products and projects that use NoSQL. Again, I'm sure you've heard some of these. My favorite is StupidDB, just because of the name. Never used it. The distinguishing characteristics, Google uses SQL and NoSQL. They have what's called Google's Big Data, which is basically to give you a scenario of where each one is better. SQL is good when you want to make sure that your data integrity is always intact, consistent, and it's durable. You're not going to lose the data because of a power outage. You're not going to get bad data because multiple people are editing it. NoSQL is basically the opposite. It's great because multiple people can change it, you need data on the fly, and you can aggregate it across multiple nodes without really having to worry about complexity of structuring your data. It's also schemaless, it's asynchronous, and it's mostly a query database, not an updated database. And I'll go here in a minute on where some of those things are actually better than SQL. NoSQL uses base transactions, which, if you're anyone here does chemistry, acids and base, right? Kind of polar opposites on the pH scale. Base does almost the opposite of what acid does. It's basically available, soft state, eventually consistent. But if any of you deal with data, that could be great or bad, right? Depending on how you want to look this and what you want to apply it to. Its biggest characteristics: it's weak consistency, availability first, best effort, approximate answers are okay. It's aggressive and optimistic, and it's simpler and faster. On the CAP theorem, this is pretty interesting. Distributed system can only support 2 of the following characteristics: consistency, availability, and partition tolerance. Now, when you deal with NoSQL, the biggest benefit against SQL is that it's easy to put out a bunch of nodes anywhere you want, to have large amounts of data available at any time. Let's take, for example, Facebook. Of course, all of your posts, your likes, your pokes, everything is stored somewhere in a SQL server. But when you have, I think, how many users does Facebook has?
Billion.
Billion? A lot. Probably all of them are underage. When you have a lot of transactions happening at the same time, there is no SQL server on the planet that can handle all the data at a single point. SQL servers are designed to have a single master node that handles all data, and it can aggregate out 2 other nodes for backup and storage. NoSQL, you could have people in India and America posting on the same post, but the changes are only written to their local nodes, and is later aggregated across the entire node network. So you can have multiple people making changes to the same thing, and it won't break anything. Availability, again, that was with nodes. Partition tolerance. Partition tolerance, there's a nice photo I have later on for that. Okay, database types. In SQL databases, most data is identified by primary keys and foreign keys. I don't know what they teach in the CS department.
They teach that.
They teach that?
Yes.
Good deal. Right, so data is almost always unique. In NoSQL, you can have key value stores, but you also have document stores and column stores. I'm not going to get too deep into that. That's like a whole other presentation all by itself. But needless to say, NoSQL, if you want to think about it in a very simplistic view, think about managing a database by using Word documents. That's kind of what a columns and document store is like. You base everything either off individual columns, or you base off documents that relate to other documents that relate to other documents. Here's some other non-SQL databases, just a couple to point out there. Column store, Hadoop, Ingress, big proponents of the column store. As for storing and modifying data, you can use HTML and JavaScript. Very good for NoSQL, mostly because the data isn't always checked and there aren't as many procedures for checking the data that's inputted. You can use other languages to interact directly with the non-SQL database. As for retrieving data, it's because you have multiple nodes across a large network, it'll go to the nearest node and pull whatever data it can from that each time. Pros and cons, I'm sure you guys see people already. You're not going to get a complete picture, but you get like 80%, which when you're dealing with big data and you need quick answers, is more than sufficient. There are some open sources for this. As for the overhead, now the biggest benefits of NoSQL, there's almost no overhead for ACID transactions because base doesn't require a lot of overhead. It's nowhere near as complex as SQL. There's very little burden of upfront schema design. It's very easy to do queries. Some people call it yesterday's technology. That's on there because of the website I pulled this from. I consider it tomorrow's technology, but it depends on who you ask. However, it puts more responsibility and burden on the programmer. SQL is really great because it takes most of the responsibility away from your development team, for languages, for any applications that might support. SQL places the burden on your application development team. Summary, just what we went over the topics. Here's a fun little picture I put up. And a little kicks and giggles, some of you guys look like you're falling asleep. Now here's a quick graphical representation of relational versus non-relational, analytic, as a service, NoSQL, operational, document, column storage, key value. You can find this online. But if any of you guys are looking for a specific product to work with, this isn't, like for example, Oracle here, they have relational and they have non-relational. As you can see, they have non-relational and relational. So when you guys are working with databases, you really have to be good at both, because if you're only good at one, yes, maybe in Google or in Facebook or some other Fortune 100 companies, you can find a specific job in just one non-SQL or SQL database. But if you're working in any medium to small-sized company, if you use any of this, you have to be good at both sides. Now, to look at the structure of SQL versus NoSQL, if any of you have taken McLaughlin's 225, this is the database as it relates to the tables, the relationships, and the columns that go to it. Have you guys taken CIT 225 databases? If you do, congratulations. If you haven't yet, I feel sorry for you. You see here, the database is very structured. You have a parent table of common lookup, member, and a system user table. Everything, all the other tables from here are dependent on it. So if you were to take this class, you have a table or your schema here, which is very, very design heavy. The pro is, now that you have a very design heavy focus, you can work with the data, and as long as you follow the guidelines and the constraints you set up, you can do a lot with the data in here, but it already has to exist, it has to be unique, and it has to follow everything else that SQL does. Now, when we go to just NoSQL, do you mind if I pull this up to write on the whiteboard?
Go ahead. Yeah.
I tried finding a nice fancy photo online, but I couldn't. How do you move them?
Don't pull out, pull down.
Pull down?
Pull straight down and let go.
Thank goodness I'm getting to the degree. Wait a little more.
If we try to project off for a second?
Sure. So that was SQL. We go to NoSQL. Your data is going to be on a single giant table. And you're going to have what in SQL you might have a primary key to determine your data. And in NoSQL, you'll have a primary key. You might have a single unique key in here to differentiate between rows of data. But as you add more data in here, and let's take, for example, Facebook. You'll have person's name, and then as their session continues on their web browser or in their cookie, the columns that are inputted in here, you'll have post 1. You might have message 1. Everything they do, almost every action they take, that will eventually write to the SQL database, gets stored in a NoSQL table, which is also stored with John, you have Rachel, Mahesh, right? All these people, all these concurrent users on the back end of Facebook are all being stored on a single table. And at the end of the day, or every 6 hours, or however long the average teenager spends on Facebook, like 18 hours, it'll commit changes from the NoSQL database table back to the SQL database. Does anyone have any questions about this at all? Feel free to ask questions, guys. Okay, that's your chance.
Can you give some example applications on what you would use a NoSQL database for, not just for Facebook, but like in any number of different scenarios that you could think of?
So,
and then we'll turn over to the next presenter.
Let's think about practical applications. I'm assuming because most of you are in CS or some CS-related minor or major, you're going to write an application. Let's say it's a video game. So let's say you're playing, say, Metal Gear Solid, right? That's a fun game. So Metal Gear Solid, you have a main character. That main character you're going to have in your SQL database. Over here in SQL, the land of structure, you're going to have your character. And you're going to have a bunch of tables that you're going to query from that essentially holds your character. Or if any of you are familiar with advanced topics in SQL, you might have a record type, right? A single long table that has all your character details. Now, when you start the game, when you start playing, you'll actually go over to a NoSQL implementation where, let's say you walk into a room full of bad guys. Right? Bad guys are bad. We don't want bad guys. We do bad stuff. So you'll have main character, and you'll have all relevant columns for the main character. Then bad guy number 1 comes along. Then with bad guy number 1, he'll also get populated along the same columns, and perhaps more, depending on his data attributes. Now what happens, these columns, a main character and bad guy 1 might have different attributes in columns, but they both house now all the same columns, because it's only a giant table. And as you go on, even like a fist fight or something, you start hitting each other. Every transaction against a NoSQL table along these columns, like you might have HP, ammo, inventory, yada yada yada. As more things are done, you'll have on-the-fly transactions and updates against the NoSQL table until an instance of these objects dies. Then he'll be taken out. His data will still exist, but it'll be inactive. And you'll keep playing. More and more data gets inputted. And maybe some of you guys have noticed when you play a game for a long time, it might get a little slow, especially with data-heavy games. As soon as you exit out of that instance of the game, it'll actually look to see if there's any changes that need to be committed. For example, if your main character were to go up a level or to gain new items in his inventory that weren't expended, these changes would then be written back to your SQL database to be stored for the next time you start the game. So it's very similar to object-oriented programming, where you have an object or object class that's then instantiated, where you make any relevant changes to it, except in this case, you rewrite the changes back to the source data. So the next time you start it up, you'll pull from the data that was written, and you'll start over again, except this NoSQL table will be fresh. Any questions? Okay. The last thing, there's a topic called sharding in databases, which is one of the biggest topics against SQL versus non-SQL. All right, seriously?
Put out.
Thank you. In your traditional relational database model, you have a table of columns, or you might have data sets, and each of these data sets are stored on different disks, or on different, doesn't have to be different physical media, but it has to be logically separated and stored in whatever your physical media is. In a NoSQL database instance, you store it by columns. Because in NoSQL, columns are king, and in SQL, rows are king. Rows being actual data referencing an actual real-life thing, and here columns. You focus by columns because you need to do a query against something. And NoSQL, it preferences columns and then returns a row.
How can be, when you talk about data with local variables and stuff like that, how can a row be faster than a column be faster than a row? Because you're saying that NoSQL is faster when you deal with big data, don't you?
So whenever you write a query in SQL, you'll do select value from table where certain conditions are met. So what it's going to do, in a relational database model, it'll look through the entire table based on that one column, or a series of columns, depending on what you're looking for, to return a single row of data. But usually, you don't have all of your relevant data in a single table, right? That would defeat the purpose of a relational database system. So you have to search through multiple tables where you have to check, make sure constraints, foreign keys, and the system has to do that overhead for ACID compliance to return back only a single or multiple rows of data, depending on how you write your query, which would guarantee either a failure or a guaranteed result. In NoSQL, whenever you write a query here, it's not going to care about ACID because it relies on base, which means basically good enough. It'll go through a column, it'll find every match, even if it's correct or not, it'll find out as close as it can and then return you a result as fast as possible. Ignoring any checks, constraints, data types, it'll just pull back data and throw it in. So if you're doing big data, which is the new buzzword nowadays, when you're doing big data, when you do searches against this, it's going to give you enough information because in statistics, you're going to have outliers. And you don't care about the outliers normally, you care about the mean, the average, right? So big NoSQL will tell you, here's all this data. You can choose to ignore the outliers, which are probably incorrect results anyways, and focus on the average, and then get your results back. Because when you're querying against trillions of rows of data, like Amazon transactions, you could have millions upon millions of transactions per day because Amazon is a worldwide marketing platform. And you want to just check everything, give me a result, what's the average transaction? And it'll go through everything, add it all up, and just spit it out at you. While if you do it in SQL, it'll go through and check everything, apply math on every step, and then give you a result after it's checked all the sources.
All right, I'm going to have to end it here and move on to our next presentation so that way we have enough time. So Dylan, you want to come up here?
Did it answer your question? Okay.
Okay. So if you have laptops, if you have Visual Studio and Xamarin Platform installed, that'd be great. That way you'd be able to follow along.
I'm actually I'm going to be talking about Xamarin today, and then,
Okay.
but is this, ooh.
No, that's for math.
Sorry, what?
That could work.
That could work on yours. Do you have a Thunderbolt?
Yeah.
That will work.
Well, this is a micro.
It's a DVI port. Thunderbolt and DVI are interchangeable. Or mini display port. That's a display port.
This is a mini display port. It doesn't.
It'll work.
Oh, okay, let's try it. Cool. If it does, that'd be wonderful, because I thought I was out of luck. My computer likes it. No. Oh, wonderful! Awesome. Okay, then I can show you guys a little bit of stuff. Okay, so to get started, I just want to talk a little bit about Xamarin and what it actually is. I just lost my whole presentation. That's all right. Okay. There we go. Cool. All right. So I'm going to be talking a little bit about Xamarin and the benefits of using it and how it can help you in your app development for really any device out there right now. There's you have iOS apps, you have Windows, you have or Microsoft, I should say, and then you have Android, right? So what is Xamarin? Does anyone have an idea of what it actually is, what Xamarin is?
Programming language that is that translator? Kind of like you translate your code into another
Yes.
platform?
Yes. So it's not a language. Xamarin is a development platform, right?
Mm-hmm.
Talking about speaking something around like stuff that's distinctive like on Linux and other OSs.
Exactly. So Xamarin is it enables developers to develop on all platforms. So as you get, who has developed apps in here before? You have a few. So a few of you have, right? Do you know what is the main problem when developing apps?
You develop for one specific target audience, and then you can develop for the other audience.
Exactly. Is the native user interface, right? Everything has a different interface and performance. And here's what Xamarin does: is it can share code across platforms using the C# and .NET framework. So, like I was saying before, iOS runs on Objective-C, Android runs on Java, and Microsoft runs on C#, right? So this creates a problem when developing. Is you have a different approach to development for each device, right? So there's one option, which is to build apps multiple times, which is obviously a bad option because it takes a ton of time. Creates one application for each device. Sorry, I did iOS backwards on there. It's actually little I, big O, big S. Which runs on Objective-C, Android runs on Java, Windows on C#, which takes time and money for big companies and things like that, because if you're developing multiple apps, then you have to hire multiple teams, right? Teams that know Java, teams that know Objective-C, and then teams that know C#, right?
You have a lot of issue in communication.
Exactly.
When you want to develop the same application, it's like, how do we do this in Java version? Like, no, it doesn't work.
Exactly. So Xamarin, well, I'll get more into it. Then there's the other approach that some companies have taken is there are platforms out there where you can create an application and then you throw it into this thing called a black box, where it will generate code and an interface depending on what you did in the application before. Does that make sense? So it's like it's a simple, easy way of taking one application and then kind of transforming it into another application, which works, but it's buggy. It's buggy. It creates issues as far. So who has an Android in here? Does anyone have an Android? Okay. And who has an Apple iPhone? Sorry. Okay. So would everyone agree in saying that the interface on the iPhone and the interface on the Android are different? Mm-hmm. Completely, right? They're completely different. So when creating applications, if you're creating an application for an iPhone and then you throw it into this black box to create an application for the Android, it's not going. The person that's used to using an Android phone isn't going to be able to use your application as easily because they're so used to using Android applications. Does that make sense to everybody?
So what would be the difference then between using black box and using the Xamarin thing? Like, how is the difference between putting it into a black box and magically getting 3 different apps and writing in the Xamarin thing?
That's what I'll explain right now. So users aren't used to the layout, yada yada yada. Now Xamarin is you have the unique approach where you kind of take the two and mix them together. So you do have to create a different user interface for each application. For example, you have the iPhone and iPad, create an user interface, and an application layer, right? Same with Android and Windows. But here's the thing, is you have a core library where you have all your code, all your C#, everything that you need to create the application. The only thing that's changing are the views, right? What you see. So that's what Xamarin's approach is everything is coded in C#, whether it be Android, whether it be iOS, or Microsoft, right? Everything is coded in C#. That way, you can create applications for all these different platforms without the mix-up of languages.
Would you translate the core library into like the three languages, or would, I mean, not translate into C#, but would it translate it to other languages?
No.
Or how is it going to do? Because it has to run in Java or Android, and then and Objective-C for the other.
I'm actually not completely sure. Yeah, I haven't looked into that. I just know that you create it in C# and then you publish it. You can publish it from Xamarin and into the different stores, and they work from there. So I don't know what goes on behind the scenes as far as translating.
So translation, the biggest thing for programming on different platforms is their APIs. Their APIs are always different. Like the way that they're named, the way that they're structured, what they do, they're different. Xamarin maps the APIs from all these separate platforms into one centralized system that handles it for you and fills in any gaps that the platforms have for you. And that's what I think it's trying to do in order to do that. You program to Xamarin's API, and Xamarin's API translates it to the native APIs belonging to each individual platform.
There you go. Yeah. Yeah. So Xamarin is awesome. So why C#, right? C# is amazing. Who's used C# in here? You have a little bit. Yeah, it's amazing. It does amazing things. Let's see. So you have links, which are language integrated queries. Adds formal query capabilities in Microsoft .NET-based programming languages. Links to objects, links to SQL, like he was talking about, and then links to XML. So, like, what was your name again?
Matthew.
Matthew. Like Matthew is saying, is it uses all of these different libraries, right? And C# is able to hook up with all of these different libraries to create amazing applications, like SQL, like objects. And the language integrated queries, I'm sure it has to do with the translation to those other languages, right? Because if you have all of these links, you're able to then translate it pretty easily using the libraries. Yeah, I'm sure that's what's going on behind the scenes, which makes the development very easy because all you're doing is you're linking to objects.
So this is a programming concept called object relational mapping. So that's the pattern that they're using.
I think you can follow the idea of the link queries.
It's connecting objects and code to objects and data. So.
Yep. Which makes development very easy because everything is done behind the scenes. There are so many different functions and libraries that you can use to do so many different things. Whereas in C++, you have to hand code everything to do everything, right? C#, there's tons of libraries that you can hook up with to do certain things. For example, coding in C# versus coding in Objective-C. This is running a what was it?
Audio file?
Yeah, it's taking the what was it? Taking the Anyway, it's finding information.
It's getting the size of the file?
Yeah, it's getting information from the file or about, it's getting information about the file, right? And in Objective-C, you'd have to go through every single little piece to do that, right? But in C#, all you have to do is one little function call to your library, and you're able to get all that information very easily. And that's why, and that's why C# is so amazing, is because you don't have to hand code everything. You can hand code things if you'd like, but there are so many libraries that you can use to help you out with your code, which obviously is very nice when it comes to application development for any kind of. So why Xamarin? I think it should be obvious by now, but you can write for every single device out there. You can write for the Apple Watch. You can write for the Apple TV. You can write for any Android device. You can write for computers. You can write for literally almost anything out there right now. You can write for using Xamarin and using one language, which is C#, instead of having to work with all of these different other kinds of languages. So here's the history of Xamarin. So Ximian was the beginning. It was founded, and then it started working with Mono. And then you guys can look at this, but in 2013, Xamarin started working with Microsoft. And then this year, in 2016, Microsoft acquired Xamarin. So it's a pretty big deal. Xamarin's really gaining momentum these days. A lot of different companies are going to Xamarin because of its usability and because of the time and money saved, right? You're obviously going to save a lot of time and money using the basics of Xamarin, C#, right? So as far as Xamarin goes, I highly recommend it, and especially to us students, whereas it's free. Other companies are paying a lot of money for Xamarin, but we get it for free. So you've got Xamarin for Visual Studio, Xamarin Studio. Okay, so I'll explain really quickly. Xamarin for Visual Studio. Xamarin has a hookup to Visual Studio because, like I said, Microsoft acquired Xamarin, so obviously they're going to integrate their products into Microsoft products. And Visual Studio is an amazing one. I recommend that one just because of its because of the libraries and because of being able to. Visual Studio is able to what's it called?
It's a full-blown IDE.
Yeah, it's able to finish your code for you, figure things out for you. Autocomplete, there's the word. Because of the libraries, because they're so extensive, the auto-completion features are very nice, and the search features on Visual Studio are also very nice. Then you have Xamarin Studio, which is also nice. I have it on my computer.
Is that another IDE?
Yes, it is.
Okay.
Specifically for Xamarin.
Yeah, but if you had already Visual Studio, it would be easier for you just to add that to Visual Studio and then use it instead of getting a whole another program just to develop.
Here's the thing, though. If you've never used Visual Studio before and you jump into it, sometimes it can be a little bit overwhelming. Whereas Xamarin Studio is just for these applications for creating apps, so it's a little bit more simple to
it's
jump
a specialized IDE that doesn't try to do as much as Visual Studio because it doesn't need to.
Exactly. Then you have the test cloud. Something that's awesome about Xamarin as well is they have pre-built applications for you. So if you're like, oh, I want to build a store, I want to build this app that has my own company store where I sell things off of, they have a pre-built app for that. They have pre-built apps for social networking. They have pre-built apps for integrating certain companies into your app, such as Facebook, GitHub, LinkedIn, things like that. They have these pre-built apps for you. It's amazing. And then you obviously would build their pre-built apps, and then you'll build upon them for your specific needs. And that's the component store. Xamarin iOS, Xamarin Android, Xamarin Mac. these are all. I'm losing my words today. Not IDEs. They pull up the.
Out of
No. It's the object itself. It's the phone or
Oh, emulators?
yeah, emulators. Gosh, I cannot remember my words today.
It's just any of them, just on computer. Anyway.
Yeah. So these are emulators. So you have your iOS emulators, you have their Android emulators, and you have your Mac
I'm really
emulators.
curious how the Mac emulator works on a Windows machine, because Apple doesn't like Windows running Mac operating systems.
Well, I wonder. I mean, I've used it because it works just fine. I mean, you can't do a. It's not like you can jump into the computer and do a whole lot of stuff. All you're doing is running your app on their device to see whether or not it functions the way it
I don't
functions.
think you can even get. Can you see
So,
the
so
Mac
this is
and
not
stuff?
really
You can see the Mac.
this. Oh, it is a full-blown virtual machine.
It's
with
not.
OS X.
No. That's what I'm saying.
iOS.
Is it's just because Xamarin is C#, it's just running the C# emulated
So it's a
Mac.
it's a simulator then.
Yeah, that's what an emulator is. It's a simulator. Yeah. So IDE platforms, like I was saying, you have your Xamarin Studio, and then you have your plugin for Visual Studio. This is kind of what it looks like for Visual Studio. Is like you can see it there. You have your iPad emulator. So, yeah.
I was gonna say, I think the question is like, do we know that it runs exactly the same in the simulator and in a real Apple device? Because there's problems when you run like even an Android thing in Android Studio's emulator and on a real Android device.
Yeah.
I think that's the biggest
There's different.
concern.
It's the operating system API level stuff all over again.
Mm-hmm.
Well, the Xamarin, that's one thing that Xamarin talks about as well. Is I'll show you their website in just a second, but they talk about how sorry, what? Oh, okay. The emulator is pixel perfect. So I'll hurry and jump to that just so you guys can see. So if we go there, what was it? The products, I believe. I don't remember exactly where it was. What was your name?
Wellesley.
Wellesley. I'm not sure exactly where it was, but on their website they talk about how it is pixel perfect. It's pixel perfect in the emulator compared to the actual device in itself. So I don't know if you're talking about the visual capabilities or if you're talking behind the scenes.
Sometimes it's like slow. Certain things are a lot slower on one than the other.
Yeah.
And things like that. Which you basically have to wait until you can get both in front of you.
Yeah. But do any of you guys have any questions as far as the as far as Xamarin goes?
What's the performance drop?
The performance drop?
Yeah.
Oh, it's an increase actually. With C#, it's faster.
Even though I did it as well.
So,
And that's what I'm not sure about still, is about the translation. I'm not completely sure.
Do you guys want to have a code space hackathon for this kind of a thing? You have to see the posters out there. Are you interested in the code
do we
space
have
hackathon?
time, though?
This is not. This could happen today. It could happen tomorrow during code space. It's at 5 Thursdays and Fridays.
Oh.
All right, is anybody interested in that?
Ed's interested.
Okay.
I have a question for you.
Uh-huh.
According to who's faster on C#?
Well, according to who? Like, according to what company?
There's
Like why is C#
Who's
faster? Who
saying
says
it's
that?
faster to do it on Swift rather than on C# rather than on Swift?
Well, here's the thing: is, I mean, I don't know who said it exactly. I don't have the exact quote, but I have read on Xamarin and through Microsoft blogs that C# in itself, the language is faster. C# is a very fast language.
Maybe compared to Java.
Oh, are you asking about in comparison to a certain language?
Well, you're talking about the
If you guys want to stay for questions, you can.
Sorry.
So you're saying that C# is faster to do what?
App development.
Yeah, that's what I'm saying. So app development for any platform or one
Yes.
specific?
For coding, you mean? For coding or
it is
execution?
faster than building an application on Swift?
Yes.
Yeah, and that was my question.
Oh, okay. According to, well, Xamarin, that's what they say. But I believe that the C# language is faster than Swift because Swift is Objective-C, but on top, so Swift is another language on top of Objective-C, right?
I don't know.
It's based on Objective-C.
It's an
It's not a native
interpreted.
on top of Objective-C.
Okay. Well, I mean, that's just what I've read. I've just read that C# is faster.
No, I'm okay with that. I just want to know if they're
No, it's an actual statement.
But became a resource. And so anybody who wants to
Sorry, what was your name?
use C# in Linux,
It's really nice to meet you. I'm John.
not
But-
it's quite yet, but maybe it will